Hello everybody, welcome to a massive open online course sponsored by Ministry of Human Resource Development, Government of India. The course is on fluid flow operations. Today's lecture will be on introduction on this fluid flow operations. So, as we know that in our everyday lives there are several products which are produced by different chemical and biochemical, even other process engineering systems to produce those products. And like if we see that we are using soap in our daily life, that soap is produced in chemical industries by a certain process. In fact, you know that some other products, like if we consider that if we use some transport like vehicles, there also you will see some extent these vehicles are processed, which will be linked to these fluid flow operations. In suppose transport processes, if we want to cross the river for get the easier transport from one bank to another bank or from one location to another location. So, there we need one bridge. So, whenever bridge is made, of course, there you have to know some extent the what will be the flow characteristics in the river, and based on which that bridge will be made. And also you will see some other different products in our daily lives. We are using the paste. Of course, this paste is one type of fluid. Now, that paste, how it is made? You have to know the flow characteristics of the fluid, different properties of the fluid, so that you will be knowing this paste is what type of fluid and what extent of this fluid, how can this fluid to be packed in a pack and it will be consumed through our daily life. Also, you will see some other in chemical industries. Of course, I told that earlier, the transport processes. Without oil, we cannot survive. Now, you cannot use that crude oil from the nature directly to your transport vehicles, so that you can easily go from one location to another location. Now, you have to process that fluid, that oil, to get it's to some extent refined, so that you are using that refined oil as a different products for your vehicles. While other type of different oil you are using for different uses, that you have to know that the characteristics of the oil. Oil is one type of fluid. You know that we are using LPG. That LPG is coming from where? That is also from crude oil. After processing with different steps in distillation unit, in distillation column, there of course, you are handling the liquid, you are operating this fluid at a particular process, so that you can separate that different components of your products like LPG, like some other heavy oils, lighter oils, kerosene, gasoline, even some other products. So, in that case, the fluid flow operations are very important, and some extent this fluid flow operations, if you know how it is to be handled, what will be the flow rate, what will be the amount of fluid to be supplied to get each different products and byproducts. And also you will see some other operations like producing this electricity, how this electricity is coming. There also some extent this fluid flow operations are directly or indirectly related. What is that? You will see that this production of electricity is by a certain process. there you have to use the gas, or you have to produce the gas from the coal. You have to process the coal in a certain way. What is that way? That is called fluidization operation. Now, that if you use this coal to produce the gas, that gas will be used to produce this power. Also, you will see that from the coal there are other several different types of gases produced by fluidization operation. You will see the production of synthesis gas nowadays, green technology, they are producing different synthesized gas to produce different products of gas. Even that gas will be being used for energy sector and for transportation and other operations. In the power plant, you will see by coal burning there is a production of steam, that by steam turbine you are producing this electricity. So, there is a process for the fluid flow operations, and then fluid flow operations you can say that it will be related indirectly or indirectly in such a way that you are handling this fluid and you are operating this fluid to get these daily life products and also energy. Another way that you can say, we will see there are so many products which is dependent on the flow characteristics, like if flow is flowing through the pipe. Now, you will see if fluid is flowing, the flow will be in different way. Sometimes the flow will be in laminar, sometimes flow will be in turbulent. Laminar means very slow motion of the fluid, turbulent means very high motion of the fluid. And also you will see if you are using the complex fluid, if you are using mixture of fluids, you will see whenever mixture of fluids will be flowing through the pipe, it will give you different patterns, and these patterns will affect the transport processes of the operations, and in that case the yields of the product depends on this flow pattern of this fluid. Now, in this course we will be learning different aspects of fluid flow, different patterns of the fluid flow, even what will be the statics of the fluid, what will be the pressure that exerted by the fluid. Whenever fluid is flowing through the pipe, you will see there will be a certain extent of pressure, and by which you will see that pressure will be as a frictional pressure. Now, you have to know what extent of that friction is being occurred by the fluid flow. So, you have to know. So, before going to the depth of those things, we will first go to the history of this fluid flow operations first. Here see, if we say that fluid flow operations, first of all you have to know what is that fluid. You know that fluid, the fluid has some certain density, we will describe it in details at the later on subsequent lecture. And here you just see the fluid may be incompressible, in that case density does not vary with what is that time, and also it may be Newtonian and non-Newtonian. You will see the fluid may be compressible, in that case density may change with respect to time and with respect to other parameters. So, in this particular fluid, whether it is incompressible or compressible, more details will be later on. Now, if we flow this fluid, you will get different patterns of flow, whether it is single flow, whether it is multiphase. In case of single fluid, If we flow it, what will happen? You will see there will be a laminar, there may be a turbulent. In that case, the S molecule of the fluid, in case of turbulent, it will haphazardly, or you can say heterogeneously, it will be flowing through the pipe. At each point of the pipe, the velocity of the fluid will not be same. So, you will get different type of pattern there. So, laminar, turbulent. Now, in case of mixture flow, suppose there is a gas and liquid flow, you will see there will be a flow of like this stratified flow. In that case, one liquid will be flowing over the other fluid. There may be a plug flow, one liquid will be flowing as a, what is that called? It is as a chunk of one liquid components or liquid bulk over other or inside the other liquid. Similarly, slug flow, similarly you will see bubbly flow. Here in this video you will see there is a bubbly flow and slug flow, some flow is there. You see there is a mixture of gas and liquid. You will see in this figure, there is a flow of gas and liquid. See, gas is flowing from the bottom to the top, and there is a certain pattern of this flow of fluid. Here gas is flowing from the bottom to the top as a bullet shape of bubbles. Sometimes some bubbles will be dispersing as a smaller size, and here see the bottom video you will see the bubbles will be dispersed as a dispersed phase of molecules, or you can say gas is flowing in a liquid medium as a dispersed phase of bubbles. And in this case you will see the uniform bubbly flow occurs. So, this is the operations. So, this one is flow, this is also flow, but how this flow will be operated for particular process to get particular products. Like one example here, if I see that this video, this is one reactor. In this reactor, from the bottom some carbon dioxide gas is supplied in a liquid medium. The liquid is being used as amine solution. This carbon dioxide gas is being absorbed in the amine solution, or you can use some other solution also. If you use sodium hydroxide solution, then carbon dioxide gas will be absorbed in a sodium hydroxide solution. So, we are using this flow, this bubbly flow for this operation of absorption. Similarly, if you use some solid particles in the liquid, you can have the operation for the adsorption of the gas to the solid surface. Even if you are using the column of distillation, you will see the liquid crude oil will be processed by its boiling point or by heating to get its several products. And suppose for drying of any paddy, suppose wet paddy to be dried or coffee bean to be dried, to be roasted in a column. So, in that case hot dry air to be supplied through the bed of the coffee bean or bed of the wet paddy. You will see there whenever the hot air will be supplied through the bed of the wet paddy or that calls coffee bean, you will see this coffee bean will be roasted at a certain temperature and also paddy will be dried. So, we can use this fluid operation for the drying. Even some other chemical biochemical processes also by fluidization is possible to produce the synthesis gas by coal burning. You are using the fluidization operation in the column. So, that is also one important process that is called flow operations. So, overall we are getting this fluid flow operations for a certain applications, for industrial applications to get our daily products. Okay. Now, we will discuss about that where this fluid flow in our everyday life is being used. Let us consider this acoustics. You know that the truck or car or bus, they are using horn, this horn by blowing of air. So, horn is the mechanism just by blowing of air. So, here fluid, that is air is flowing. So, fluid basically liquid, air and some other form like plasma. So, in this case we are considering that liquid and air. And also you will see in our daily life, see this picture or video, see in our coffee, if I add some milk as a jet, what will happen? The milk jet and the coffee, it will be mixed. So, here in this case the mixing of coffee by turbulent jet of liquid. And also you will see some rotational flows in our daily life. In your toilet, after flushing, what you will see? There will be a circulation of the liquid. So, there is one operation here. So, liquid, fluid flow, liquid flow. Another point is that non-Newtonian fluid flow, paste, whenever we are taking out the paste from the pack, you will see there will be a flow of paste. This paste is one type of non-Newtonian fluid. We will describe in details about this non-Newtonian liquid later on. So, this toothpaste is one type of non-Newtonian liquid, and having this toothpaste from its pack is simple this way. Now, aerated jet flow, you will see washing mouth or hand. So, this is here see this is aerated jet, air and liquid both are coming from the tap as a jet. So, we are using that for hand wash, mouth wash. Drying of hair, you will see in our daily life what we are using for drying our hair. For drying our hair, hot air to be supplied through the jet, here it is called hair dryer. So, from the hair dryer, hot air is being jetted to this hair, so that it will be dried. Other like a splashing, in this case by liquid, we are splashing the liquid in our mouth. Okay. Flow of liquid drops, you will see sometimes we are using the liquid drops in our bathroom from our showers. Forced convective flow, you will see there will be a fan. In this case, air is flowing by force from its fan, that is called convective flow. Flow of buoyancy driven plums, other example. You will see liquid flow by atomization whenever we are painting our wall. The paints is coming from the spray as a atom, very fine droplet of faint liquid. So, in that case liquid flow by atomization. Similarly, we can say that free surface flow in the channel, you will see in the river, you will see there will be a flow of water. The water will get the free space, free surface to flow. Another example, you will see in our vein there will be liquid flow. Now, liquid is flowing very slow rate. So, it is called the streamline flow. You will see there will be a drop coalescence, and this you will see there will be successive drop. If the drops are coming to each other, in the picture you will see both the drops are coming to each other and joined, you will see there will be a big drops formation. So, this phenomenon is called coalescence of drop or drop coalescence, and this is sometimes to control the surface for a particular operations. The coalescence process is important. Have you seen the Waddington jets? This is how the jet is formed. If you drop some object on the surface of the liquid, you will see pool of the liquid will be coming as a jet from the surface. So, this type of jet is called Worthington jets. Hydrophobic surfaces, you will see this is the hydrophobic surfaces. In that case, you will see the water droplet in your, you will see on the leaf the surface how it is being bent towards this surface, that is water is repelling from the surface. Aerodynamics, you will see whenever aeroplane is flowing, what that there will be lift of plane, and also there will be downward movement, upward movement of the plane. Also whenever there will be a car flowing surrounding the car or aeroplane, you will see there will be a flow of airs. Now, there will be a friction of airs whenever it will be flowing over the surface. So, there will be certain frictions, you have to maintain certain extent of flow to get reduced this friction. Also, you will see, have you seen that there will be a particle laden flow in the storm, you will see the storm dust is flowing over the surface of the land. So, that is particle laden flow. Lift, how much lift of aeroplane does? Bio-inspired fluid flow, whenever you will see if animal is taking the water from the, that is any bucket or any pond or any river, by their tongue, you will see they are lifting the water, lifting the liquid. So, this type of things bio-inspired fluid flow. Multi-phase flow, there is several applications of this multi-phase flow, gas liquid flow, gas liquid solid flow for the operations to get the synthesis gas, to get the synthesized products, to get the power by burning the coal, that is a multi-phase flow. Evaporative flow, you will see there will be air heater and cooler, flow through porous media in our daily life. What happened? We are using filter for drinking water. In that case, water is flowing through the porous media like candle. Candle is nothing but a porous media. Now, question is that all these fluid flow operations, of course, it is related to the products of our daily lives, how it is processed to get these products, and everywhere in chemical, biochemical or the design of any mechanical devices, this fluid flow operations is related to the design and also to get the optimum characteristics of the unit or device for the particular uses in the process industry. In this case, then there will be certain signs of this fluid flow, what you are going to use for the particular processes to get our daily products. So, what is the science of flow? So, what is that particularly? This science of flow is actually started from very beginning. So, we will say that what is that actually start of that fluid flow we will discuss here. So, in this case science of flow we can classify it into hydraulics and hydrodynamics. So, in this case what is that hydraulics? Hydraulics is purely empirical science and which developed from the experimental studies. Based on the experimental observations, how this flow, mechanism of the flow can be denoted by mathematical formula, or how can express these happenings or science of the flow by mathematics. So, this in the hydraulics is the science of the flow that will be basically the empirical science which is developed from the experimental studies. Hydrodynamics also it is developed through theoretical studies based on the experimental observations. So, in this case the science actually developed based on the energy and momentum balances and also some other material or thermodynamic law. So, based on that science or theory, this hydrodynamics of this flow is being actually developed. And however, both have this hydraulics and hydrodynamics have some extent the similarity. So, nowadays this hydraulics and hydrodynamics both have merged into the single discipline, which is called fluid flow operation. And if we see very beginning or see that transportation of the fluid, how it was happened in the early 4000 years BC, and it was first discovered in Egypt and Mesopotamia through a irrigation channel in 4000 years BC. And transportation of the fluid effectively depends on the proper design of conduit through which it flows with less friction and less corrosion. At that age, it was seen that whenever fluid is flowing through the channel, there will be a certain friction of the fluid with the wall of the channel, and based on which that engineer or the expert, the hydraulic engineer, hydraulic expert, they have designed this channel for their irrigation purpose by considering what will be the friction, what will be the corrosion of the fluid whenever it will be flowing through the conduit. That is why from that period onward, the huge invention and progress in overcoming these hydraulic problems was considered. In this case, you will see this is the channel, that through the channel the fluid is flowing and how liquid is flowing there. And if we go to the age of 1452 to 1519, interesting that the history of hydraulics is given by that Leonardo's. Now, Leonardo's note, he has described some fluid flow phenomena, how water is moving and eddies of water, how it will be moving, and also how the water makes waves, and whenever water is falling down, and also how the destructive force of the water is prevailed, and also the floating bodies, how it will be behaving whenever it will be flowing over the surface of the liquid. So, he has I think 1452 to 1519, he has described all these fluid flow phenomena in hydraulic machineries. And also Leonardo da Vinci, he was one of the pioneer I think investigator, and he forecast some laws such as the drag whenever fluid is flowing through the pipe or channel, how this fluid is moving, and whenever it will be flowing, how drag is formed over the surface of the solid, even whenever a jet of liquid is moving, and when liquid is falling, how it will behave, what will be the flow pattern of this fluid, he has given in details at that period. He also advocated the observation of internal flow by floating particles in water by visualization of the flow. And very interesting that the advent of the hydrodynamics, this tackles the fluid movement both mathematically and theoretically, and it was first considerably described by I think Leonard Euler in 18th century, and he has given some theoretical equations for the flow of non-viscous, non-frictional fluid, were derived by him and other researchers. In the 19th century, the equation for the movement of viscous fluid derived by Navier and Stokes. Later on, in 1869, Kirchhoff, a German physicist, 1824 to 87, and he reported the some relationship of the hydraulics to the hydrodynamics, and he computed the coefficient of contraction for the jet from a two-dimensional orifice as 0.611. So, from then onward, they observed that there will be a certain barrier between this hydraulics and the hydrodynamics. Now, that barriers, whenever they have described in terms of different laws of or different phenomena of the fluid flow, they have observed that actually there was no barrier between that hydraulics and hydrodynamics. These two terms, these two sciences are almost similar, and they are related to each other with a certain platform. So, in that case, that the barrier between that hydraulics and the hydrodynamics completely removed, and the field of probably on the eve of a big leap into a new age has come from then onward. The fundamental principles of the hydrodynamics and dynamics, these fundamental principles has started from a certain milestone of the fluid flow. So, we will describe here the several milestones from which the fluid flow operations and the phenomena of the fluid for the different aspects, for the design of different hydraulic machinery, for the different fluid flow operations in the different chemical, biochemical and mechanical processes, even civil engineering processes also. So, in that case, some milestones of the science has come out. The milestones starts from the Archimedes from 250 BC. The Archimedes has given the fundamental principles of the buoyancy of a floating bodies around 250 BC. And after that, about 120 BC, another Roman mathematician, he has constructed a hydraulic machinery based on the principles of this fluid flow, and he explained that the machinery is designed or can be designed based on the frictional contribution of the fluid for a certain operation. And also later on, at the same century, Ctesibius and Hero, they have observed that there will be a fountain of compression, the siphon and the forcing pump. They have invented those things. Though they were mathematicians, they are not engineers, but based on the principles of the fluid flow, they have invented this forcing pump. And also some methods for ascertaining the quantity of water discharge given by Sextus at Rome at 1st century AD, and he has formulated some techniques how to measure the quantity of water which is discharged from the tube and distributing it in a certain operation. After that 1115 to 1130, Islamic scientist Abu Rehan Biruni, 1130, they have first applied experimental scientific methods on fluid statics to estimate specific weights in their location, this is in Baghdad. And in the 9th century, Banu Musa brothers, they are actually Persian scholars, they have described a number of early automatic controls in the fluid flow. The Banu Musa also delivered an early fail-safe systems for controlling amount of the fluid flow. After that, in 1206, Al-Jazari's description of the various mechanical devices as hydraulic machines turned to the discovery to the design of various hydraulic machines based on the methods they were used. Al-Jazari also invented a twin cylinder reciprocating piston suction pump based on this Al-Jazari's initial principle, and this include the first suction pipes and made early uses of valves. After that, they have converted of this rotary pump to the reciprocating pump by their principle of motion. Later on, 1628, Benedetto Castelli and Evangelista Torricelli, the disciples of Galileo, they have applied the discoveries of their master to the science of hydrodynamics. And in 17th and 18th centuries, also several other phenomena in the motion of fluids in the rivers and canals they have observed, and based on their observation in 1643, they proposed that the velocity of the water will be proportional to the depth of the orifice below the surface of the vessel, and the velocities of the liquids which are flowing will be the square root of the head of the fluid flow. And whenever the flow of fluid, there will be certain resistance. If it is air, there will be resistance of air, and whenever air is flowing through the orifice, there will be certain friction, and this frictional quantities of the air or so other liquid, whenever it will be discharged from the different vessels, there undergo some pressures. So, at different pressures, at different resistance, at different frictional resistance, there will be a certain pressures. So, those pressures will be coming out from the discharge, and it will depends on the quantities of the water, how much it will be discharged. So, this resistance will give you the amount of discharge of water or fluid coming out from the vessel. So, that is proposed in 1648. After that, in 1663, the dignity of the science on the equilibrium of liquids by Pascal, which was one pioneer French mathematician and also physicist who has given the one significant milestone for the discovery of the science, and based on his discovery of the dignity of the science and also the phenomena of the science of the fluid flow, Edmond Mariotte in the year 1686, he is a French physicist following that Pascal's, he has given some theory on phenomena of the fluid motion, and he has also followed the theorem of the phenomena of the fluid motion based on the Torricelli's principles. After that, between 1655 to 1710, The D. Guglielmini, Italian mathematician and also chemist, you can say he is also physician. He has observed that diminution of the velocity in the rivers to transverse the motion arised from the inequalities which is observed in their bottom part of the river. After that, in 1687, the several branches of hydrodynamics was come out, and it was described by Sir Isaac Newton, and he has observed the different effects of friction and the viscosity in reducing the velocity of the running water, and also he has observed some vortex phenomena of the fluid whenever it will be flowing in a certain conduit, and he observed that the velocity of any stratum of a vortex will be an arithmetical mean between the velocities of the strata which enclose it. Like this here, these are the strata, and what will be the velocity of this strata? This velocity will give you the vortex, and the velocity of this vortex that depends on the velocity of the strata. After that, in 1713, Isaac Newton discovered a contraction in the vein of a fluid, that is called Vena Contracta, and this contraction in the vein whenever fluid is flowing through it or issued from this, he found that at the distance of about a diameter of the aperture of this Vena Contracta, the section of the vein was contracted in the subduplicate ratio of 2 to 1. He was also the first investigator of the motion of the waves. So, he has first observed this Vena Contracta phenomena and how this circulation of the fluid happens surrounding this vein of the fluid in the contraction Vena Contracta region. And after that, there is a you can say significant discovery for the Pitot tube. Henry Pitot, around 1771, he has discovered the French hydraulic machine. It is called Pitot tube. He was also French hydraulic engineer, and by which he has measured the what would be the flow rate of the fluid, and according to that Pitot principles 1732, the height of the fluid column will be proportional to the square of the velocity of the fluid at the depth of the inlet to the Pitot tube. So, based on these principles, still now the velocity of the fluid through the pipe, how it is measured. See, here it is, the formula is given that depends on the head of the fluid and velocity, and this velocity is measured by this, what is that, Pitot tube. The principle of the Pitot tube will be described later on in a subsequent lecture, will be there. The relationship was discovered when he was assigned the task of measuring the flow in the river Seine. After that, in 1738, de Bernoulli, which was a Swiss mathematician, revealed his theory of the motion of fluids. He observed that if the surface of the fluid contained in a vessel in employing itself by an orifice remains always horizontal, and also if the fluid mass is conceived to be divided into an infinite number of horizontal strata of the same bulk, the strata remains contiguous to each other. He also pointed out that whenever liquid is falling downwards vertically with a certain velocities. The velocities inversely proportional to the breadth or to the horizontal sections of the reservoirs from which the liquid is falling down. And also based on the motion of each stratum, he also been employed to obtain the solution of the conservation of the energy whenever fluid is flowing through the pipe, and he also determined the solution and also got the elegant solution for the movement and conservation of the energy, how it will be consumed in the flow of fluid. After that, few years later, in 1743, J.L.R. D'Alembert, he has also suggested the principles of motion of fluids, and based on his principle of motion of fluids, he has given a specimen of its application or suggested a specimen of its application at the end of his and publish article Dynamics in 1743. In 1744, in the subsequent year, he also revealed one relationship between equilibrium of bodies and the motion of fluids, and he has developed a nice relationship, this equilibrium with the motion of the fluids by the same assumption which was made by D. Bernoulli earlier. After that, more than 30 years, in 1777, A.C. Bassett discovered the resistance of the fluid in 1777, and in 1786 also Dubois, most successful experts in hydrodynamics, founded satisfactory theory of the motion of fluids, and he pointed out as the motion of the rivers is not continually accelerated and soon arrives at a state of uniformity, it is evident that the viscosity of the water and the friction of the channel in which it descends must equal the accelerating force. After that, 1801, I. Telwin of Berlin investigated a valuable compendium of hydraulics, the discharge of water by compound of pipes, the motions of jets and their impulses against the plane and oblique surfaces. He showed theoretically that a water wheel will have its maximum effect when its circumference moves with half of the velocity of the stream. Jean Nicolas Fee Hassetti and others investigator reported experimental observations in between 1816 to 1817 on the spouting of the fluids. After that, Poncelet and Lesbros did their extensive experiments on the discharge of the water, and which was the one important milestone to discover the orifices and how it was working to measure the discharge of the fluid. And J. B. Francis, after that 1855, they have published their proposed formula for the flow over years. This is also one important milestone for the civil engineering discoveries. Later on, Henry Darcy, they continued with H. Bazin for the study of flow of water in pipes and channels in 1866. Later on, in 1867, P.G. Tate published the hydrodynamical equations which expresses vortex motion based on the laws of vortex motion that is given by Hermann Helmholtz in 1858. Einstein, after that 1924, after several years later, and he has given one even wonderful theory for the conservation of inviscid fluid circulation around a material contour. They have discovered how the energy is transporting in the inviscid fluid whenever it will be circulated around a material. The conservation was proposed by Lord Kelvin, and he was the first Baron Kelvin, a Scot-Irish mathematical physicist and engineer as well. After that, in 1932, you can say this, the it is called Lamps. Lamps discovered the characteristics of the hydrodynamics based on the vorticity and vortex dynamics. And then G. K. Bachelors introduced the fluid dynamics in 1967 and published the well depth of different aspects of hydrodynamic. After that, in 1975, Novikov and in 1979, RF revealed their important investigation on the chaotic advection, and then the subsequent elucidation of chaos in the advection of passive particle by three vortices based on the previous, that is, principles of the vortices, and which will be directed to the modern science for the fluid flow operations. After that, 1992, Phillips, Geoffrey, Schaffman, he described about the vortex motion in details and also vortex dynamics and the vortex flows in more details for the application in the several processes. In 2008, later on, this one is also important milestone, and this is Celero. He has published the genesis of the fluid mechanics, and after that in the subsequent year there are lot of research is going on, and different authors, different investigators, they have published lot of works on the fluid phenomena. And one important aspects in 2011, the Davidson et al. They have worked on the extensive studies on the voyages through turbulence and how this turbulence will be affecting the different processes and how it can be minimized and how it can be maximized for the beneficiation of the process yield, and from then onward there will be more research on the fluid flow till now, and it is being continued. Then question is that this is the history. After that, knowing this history, there are several works, several investigations is going on the fluid mechanics and fluid flow operations. Now, why the people should learn the fluid flow operations, or why one should learn? Everybody cannot learn. So, where, who is actually learning this? Of course, this is important for the process engineers. So, process engineers are very interested in the systems that will be involving the flow of fluids, and that is why interest is going on to the fluid flow operations, because this fluid flow operations is directly related to the process yields. So, in that case, for the design of various equipments, various process equipments, and the development of the process, even intensification of the process, it is very necessary to know the fluid flow operations, by the process engineers. So, process engineers, of course, interest occurs at the two levels here to know these fluid flow operations. One is the practical level, which is actually consists of calculations of the fluid flow, which is required for the design of chemical engineering processes. And the second one is the conceptual level, by which the engineers or process engineers, you can say, they should learn the fundamental of the fluid flow, the physical properties of the fluid, which is required for him to solve the practical problems in both effective and elegant ways. Also, you will see that this fluid flow calculations, that will include several things, like how pipe network will be designed, that depends on the fluid flow, because the sizing of the pumps that depends on the discharge rate of the flow and the pipeline through which it will be transported. So, through the pipelines, whenever fluid is be transporting, there will be some frictions. So, you have to know the friction mechanism and also the fundamental of the frictions. Also, the effect of fluids on the, you will see there will be different operations for the heat, for the mass, for the reaction, and also for the separation processes. In our daily lives, you will see the heat transfer equipment, for the mass transfer equipment, like suppose crystallization, this is one mass transfer equipment. There will be distillation column, mass transfer equipment, absorber, mass transfer equipment, packed bed operations, where the adsorption of the contaminants of the liquid to the surface of the solid particles, this is one type of equipments. So, whenever design these equipments, you have to know the fluid flow phenomena there. So, this fluid flow phenomena will give you the yields of the rate of the heat transfer, yields of the rate of the mass transfer, yields of the reaction rates, yields of the separation systems. And also for this, the process yield based on this fluid flow operations, you have to know the characteristics of the fluid, because if you know the fluid characteristics, then what will be the fluid is flowing, what type of fluid is flowing, what will be the physical properties of the fluid, how friction is happening, what will be the rate of the fluid or flow rate of the fluid inside the reactor, what extent of friction during the fluid, what will be the circulation velocity of the fluid inside the fluid, that depends on the fluid properties. So, all design parameters of the transport processes depends on the fluid properties. And also you have to know, or engineers should know, the fundamental ideas needed for the fluid flow. You should know the conservation laws, which is very important and which has three most important parts. One is conservation of mass, conservation of energy, conservation of momentum. By these three laws, one can solve the process parameters for the heat and mass transfer for the particular separation processes for mass transfer operations, and also fluid phenomena inside the equipment, how it is happening, what is the flow pattern, how energy is distributing, how the concentration of the fluid elements will be distributing throughout the column or reactor, that will be solved by this conservation of mass, conservation of energy, conservation of momentum. These three conservation laws will form the basis for the developing fundamental understanding of the fluid flow. And to express this mathematical form of the process yield or design parameters or the phenomenon of the fluid inside the conduit or inside the reactor, inside the equipment, the mathematical expressions are classified into three or described by three equations here, that is called the continuity equations, the Bernoulli's equations and the momentum equations. Let us see one example here how fluid flow operations will be related to the equipment for the particular chemical engineering processes. Here see one processes here. In this case, one reactor is being used for these processes to yield the different products and byproducts, and feed here. The feed is transported by a pump through pipe to the reactor, and from the reactor through the pipe the unreacted feed is coming, and it will be sent to through the pipe by pump to a separator, and also unreacted feed products and byproducts it will be sent to separator. And in this separator, after certain chemical processes, the products will be separated into various types of products, these products and also byproducts. So, for this to send from one equipment, one unit to another unit, the pump is required, pipes is required, and also for the process the different units are required. So, in this case you will see the relevance of the fluid flow to the design of the process unit are pipes. So, in this case streams are conveyed between processes via numerous pipes, which contributes a large fraction of the capital cost of a chemical plant, and so need to be sized appropriately. And if you are using pumps, it will make the fluid flow along the pipes. They need to be sized to deliver the required flow rates, while their power consumption contributes to the operating costs of the plant. Reactor, also the nature of the fluid flow patterns determines the way that molecules meet each other and react, and hence the yield throughout and selectivity of the processes. Heat exchangers, in this case heating or cooling operation, but there may be many in the process, and the rate of heat transfer, and therefore, the size and cost of the heat exchanger depends strongly on the fluid flow patterns. In the separation processes, in the separator, of course, the probably via distillation for getting the different byproducts, in which flow patterns of the liquid and the vapor phases, which will affect the mass transfer between them. Other applications like fluid flow also has an enormously wide range of application outside of chemical engineering, in particular civil and mechanical engineering, in meteorology and oceanography to know the weather patterns and the ocean currents. In medicines, like how blood is flowing through the vein, mastery of fluid flow can open up a wide range of employment and research opportunities both within the chemical industries and beyond, like software industries. Example like fluid flow, Fluent, COMSOL, OpenFOAM, etc. are using different softwares, and they are making softwares, and these softwares are made based on the principles of the fluid flow. So, I suggest to read more about this fluid flow operations, and you can follow the Wikipedia and also some other references here. So, thank you for your patience, and we will be discussing in the subsequent lecture the main part of the courses, that is the fluid, what is the fluid statics, how fluid will be actually represented by different equations, fluid phenomena and other parts. So, in this lecture only the fluid flow operations, what is the history of that fluid flow operations, how these fluid flow operations are related to the different processes, whether it will be chemical or biochemical or civil engineering processes. Some extent it will be related to the other engineering processes. So, fluid flow important for that, and this is directly related, or you can say some processes it will be indirectly related for the yield of the product by that particular processes. So, thank you.